All right, welcome back, 7th grade. Today we're pushing into problem 4.2, finding the slope of a line, and we're going to be doing a couple of fun things along the way. Here we go. All right, so finding the slope of a line. The method for finding the steepness of stairs suggests a way to find the steepness of the line. When we did this with the stairs across the street from my house, or what we saw in the book, we saw this process of this rise and run, rise and run, rise and run. There's that vertical change over the horizontal change to give us that steepness of the line. We're going to call that the slope. It's another new word that we have describing that rate or the ratio of two different parts. And what we're going to be looking at is this is another name for the same thing we had with the scale factor, with unit rate, with constant proportionality, so many other different processes. My mind is a little blank today, but the slope is the new term we're going to have. And as you see, it's the vertical change, which is the rise, over the horizontal change, which is the run. So we need to understand that the slope is going to come in multiple ways. First thing we have to look at this, we have a positive slope, this going uphill. If we're going from left to right, you can see it'd be going uphill. That's a positive slope. And then this other part here, if I'm going from left to right, this would be a negative slope, kind of a going downhill slope. All right, so what I want you to do right now is pause this video, and I want you to go to watch the Slope Dude video that I posted along with my videos, so you get a sense of their connection between the positive slopes, the negative slopes, as well as a zero slope and an undefined slope. So we're going to do that now. All right, I hope that was helpful. We got to remember that anytime there's that positive, it's going to be looking like it's going to be going uphill, that puff, puff, positive. And then the negative slope is going to be coming downhill, okay? So we got to make sure we remember those processes as we see these slopes come together today. All right, let's look at our work for right now. All right, here we go. So it says here, part A, the graphs, tables, and equations all represent linear relationships. That means there's going to be a slope that is going to be constant, at constant rate in that. So we have graph 1 and graph 2, table 1 and table 2, equation 1 and equation 2. So number 1, it says, find the slope and y-intercept of the line associated with each of these representations. And then write an equation for each table and graph. All right, graph 1. So we have this process of looking at, we have a bunch of little line coming down. It's going to be a downhill thing from left to right. It's going to be down. So it's going to be a negative slope in this case. And I know this is early in that process, but let's take a look at a couple ordered pairs so we can understand what's going on here. So I'm going to go through and look at all these values here. So I see right away, I see a -1, +9, so I have an x, and I have a y. So I'm going to draw this table out here. So I have a -1 and a +9. I have a 0, 6. I have a 1, 3. And I have a 2, 0. I have a 3, -3. Okay, so we have those ordered pairs there, and we're going to look carefully at what's going on between these. First of all, it's the change of the y. Remember, we have the change of the y over the change of the x. So what's happening is I go from 9 to 6 to 3 to 0 to -3. This process is going to be, it's a -3. It's a constant -3 of each of these. So that means the change of the y is going to be a -3 up on top. Then up here, you see if I go from -1, 0, 1, 2, 3, it's going to be a change of +1 and +1 and +1 and +1. So that means I'm going to have a +1 here. So that means the slope in this case would be a -3 over 1 or plain old -3. All right, graph 2. Same kind of process, but now I'm going from left to right. It's going to be going uphill. It's going to be showing it's a positive. So I'm going to be looking at all these ordered pairs again, and I'm going to start here at this guy. I can see that I've got a -3 and a -3 right there for my value. So I'm going to have a -3, -3. And I'm at -2, 0. I'm at -1, 3. I'm at 0, 6. and then at 1 and 9. All right, so that same process. Remember, it's going to be the change of the y over the change of the x. So what's happening for my y's? I go -3, 0, 3, 6, 9. Hey, that's a +3, and a +3, and a +3, and a +3. So that means my change of y is going to be a +3 in this case, over what's happening here. -3, -2, -1, 0, 1. This is all going to be a +1, +1, +1, +1. So that's going to be a change of that 3 over 1, which is a plain old 3. All right, moving on. Table 1. So you see with this whole table here, ready to go. I copied it into my notes. We can do the exact same work that we had before. So remember, it's a change of y over the change of the x. So as I'm going here, -10, -7, -4, -1, 2, 5. I'm seeing a constant of a change of a +3, +3, +3. Hopefully you guys are seeing that too. +3. So I have a +3 here. And up here, I have a -6, -4, -2, 0, 2, 4. This is going to be a +2. So that means I have a 3 over 2 slope, which means my slope is 3 over 2. Or if you wanted to put, you can put 1.5. But you'll see we're going to want to leave it as 3.2 in the future. All right, table 2. Here's what we have. We're looking for our change of y over the change of x. So if I go from a 4.5 to 4.0 to 3.5 to 3.0 to 2.5, 2.1, I actually see a minus of a 0.5, minus 0.5, minus 0.5. All the way, that means it's going to be a -0.5 on this one. In this case up here, it's going to be 1, 2, 3, 4, 5, 6. It's going to be a +1, +1, +1 the whole way. It's going to be over 1. So it's a plain old -0.5, or you could put a -1/2. Either of those would be okay. All right, equation 1 and equation 2. So based on this point, if you recall, the equation form is actually going to be the most direct one for us to look at. And I want to make sure we go back and remember something from problem 4.1. So let me go back and take a look at something here real quick. If you recall, the very, very beginning of this process, they were showing us that this is all about the steepness of a graph. The coefficient m of x graph is this equation, and that m represents that slope in this case. It's going to always be that slope. We also are going to know something about the y-intercept in just a second. So basically, these are straightforward here. The slope in this case is going to be the letter m, and the slope is going to be, and we'll put m in this case, 2.5. Same thing here for equation 2. Whatever's with the coefficient of the x, it's going to end up being that the slope is equal to -3. Now, one thing that we did forget to do is we had to go back and for all of these, put in the y-intercept as well. And the trick for the y-intercept is, make sure we have this, so y-intercept is equal to the value of y when x equals 0. Let's go back to all of these and put in 0 for x. So first of all, hey, I see 0x right here. So that means x is 0, so the y-intercept is going to be 6. So I'll put that y-intercept, we'll abbreviate that, equals 6. Same thing here. X is 0, y-intercept is 6, so y-intercept equals 6. You throw all values here. Okay, x is 0, so that means a y-intercept equals -1. And this one's an interesting one. We don't have 0 on here, but we actually could pretend that we put 0 back here. If I had 0 back here for x, see I was going +1, +1, +1, I would have to do a -1 this way. So this was all -0.5, -0.5, -0.5. So I would actually come back this way. It would be the opposite of a +0.5, which would give me 5. So this is the y-intercept equals 5 in this case. And on to these, if I put 0 in here, 2.5 times 0 would be 0, so that means that the value of y would be 5. So that means the y-intercept equals 5. Same thing here. If I put 0 in here for x, so negative 3 plus, or sorry, times 0 would be 0. So my y-intercept would be 20. All right, part 2. We're asked to write an equation for each graph and table. All right, so going back here, notice how for graph 1, we had the slope was negative 3, y-intercept was 6. Up here, if you recall, remember how we just had the slope, or that equation here is going to be a 2.5 for the slope. Y-intercept was 5. So we take both of these guys and plug it right in. And so we would actually have our equation would be y equals negative 3x plus 6. And we just take that information and plug it right in. For graph 2, the slope was 3, y-intercept was 6. So write that down. Slope equals 3, and y-intercept equals 6. So that means the equation for this one would be y equals 3x plus 6. Same process here. For table 1, we have a 3 over 2 or a 1.5. Either of those will work. And our y-intercept is negative 1. So slope is equal to 1.5. Y-intercept equaled negative 1. So that means we'd have our equation would be y equals 1.5x minus 1. And then for table 2, our slope was negative 0.5. And then our y-intercept was 5. So that means our equation would be y equals negative 0.5x plus 5. All right, on to part B. The points 3, 5, and negative 2, 10 lie on a line. So what's the slope of that line? Find 2 more points that lie on this line. Explain your method. And then we have another question there about that. So let's take a look at this here. So the first thing I want to do though, guys, is I want to show you a new formula that's going to be really important for our work here. It's going to be called the slope formula. And what it is m is equal to y2 minus y1 over x2 minus x1. And what that means is, in this case, if I have my 2 points, I'm going to pull this one specifically from what they have here for part B. Part B, they give us the 2 points. They give us here 3, 5, and negative 2, 10. So we said that this was point 1 and this was point 2. Don't forget that this is written in the structure of understanding that we have an x and a y value. So that means that this is x and this is y, this is x and this is y. So what we would do is we'd take this information here and we would plug all those pieces in. So I would have my slope, or the letter m. Don't forget that that letter m is referring to the slope in this case. So what we have here is y2. So we've got 0.2 and letter y, it's going to be a 10 minus y1, which is going to be 0.1, and the y value there is going to be a 5. Then we take x2, so 0.2, which is actually going to be a negative 2, minus x1, which is going to be 0.1 and a 3. We're going to do this subtraction. So 10 minus 5 is 5. Negative 2 minus 3. Now don't forget, subtracting from that, like a negative 2, we had to add the opposite. And then we have same signs, add and keep. So I have a negative 5 here, which when I simplify that, I would get a negative 1 slope. And that's how that would work.